Der Hamburger Hafen ist ein Hafen mitten in der Stadt.
The port of Hamburg is situated in the middle of the city. Its location makes it quite unusual, so that among other issues, we have to reconcile transshipments in the port with the fact that it is a residential area.
Wir haben einen stündlichen Brennstoffverbrauch von 1,2 Tonnen, auch im Hafen.
Our hourly fuel consumption is 1.2 metric tons, even when operating in port. So if the shore connection is synchronized, we can shut down the diesel engine and save an enormous amount of fuel. This cuts exhaust emissions to zero in the city over the entire lay time, which can be as long as 10 hours.
Mit der Langstromversorgung können die Schiffe, ob Kreuzfahrtschiffe oder auch andere Schiffe.
With the shoreside power supply, ships, including cruise ships and other vessels, can shut down their diesel engines in port to be supplied with clean energy from shore. This is a purely environmental concern, one that the EU has been proposing for years with directives and which is now in the process of being implemented. Power is supplied to the 50 Hz medium voltage switchgear, from where it passes on to the 50 Hz transformers that transform the power to appropriate values for SeepLink, which is the heart of the frequency conversion process. The SeepLink output is converted into the appropriate frequency and voltage values and then passes via the output transformers and corresponding cables directly to the quay wall and onto the ship.
Wir haben hier in der Kaimauer einen Kabelkanal.
Here we have a cable trench covered with steel plates in the wall of the quay. This duct contains a cable chain so that the cable does not lie on the quay and no one can trip or drive over it.
Die große Herausforderung bei der Entwicklung des Kabelzuführungssystems war die Differenz zwischen
The difference between high tide and low tide, which turned out to be a total of 8.5 to 9 meters here in Hamburg, was a major challenge in developing the cable management system. It's a challenge you find only in the rarest of cases, if at all, anywhere in the world, so the system is tailored specifically for Hamburg. Today we can say that the device in operation here in Hamburg could basically be used in smaller systems around the world with no major modifications.
Die landseitige Stromversorgung wird über einen Roboterarm über Kabel in das Schiff geführt.
The shoreside power supply is fed into the ship over cables, using a robot arm. It is plugged in a shoreside connection room, provided specifically for this purpose. After connection, the shoreside power is synchronized with the voltage of the ship's generator. When the voltage is synchronized, we shut down our generator on board, after which the machine room is quiet, with the result that no more exhaust emissions are produced.
The entire project implementation went very well. We had a very tight schedule for carrying out the project and had to work continuously, primarily in winter, especially the underground work on the quay. We had to do this at times when no cruise ships were being processed because this would have interfered with the entire cruise service at the terminal.
We received the order for the Hamburg Altona shoreside power supply system for cruise ships in our capacity as general contractor, and we're proud to see this system now going into service after years of preparations.